Moon plummeting to Earth might seem like something out of a strange science fiction story. But if it really were to happen, then there would be a certain symmetry to it all. The leading theory for the moon's formation is the giant impact hypothesis, otherwise known as the Big Splash theory. It says that around 4.5 billion years ago, the early Earth collided with another large body about the size of Mars, named Theia, and that this collision created debris that then coalesced into a molten ball and began to cool, to become the moon. So if this ball in the sky ever headed back towards us, it'd really be a case of it returning home. But it wouldn't be much of a feel-good story. Ever since its formation, the moon has withstood countless smaller impacts of its own, and these have pockmarked its surface with various craters, many of which can be seen with the naked eye. But all in all, the moon has remained stable in its continual journey around our planet, and it hasn't been significantly moved by any asteroid careening into it, which is pretty fortunate for us because this 2,150-mile wide orb is fairly essential to how life on Earth works, reflecting sunlight back to us as nighttime and exerting a gravitational influence over us, most notable for how it dictates our tides. At its current distance away from us, which is around 238,000 miles on average, the moon's gravity is responsible, with some help from the sun, for the rise and fall of the ocean. If it were to begin moving towards us then, one of the first signifiers would be a change in how the sea moves. Even if this were a slow and gradual process, the effects would still be devastating, because tides play a number of important roles, like spreading corals for reef development all over the planet. Various animals, including birds as well as sea creatures, also rely on the moon and the tides to guide their natural instincts for migration. And the moon and tides also have some influence on our weather systems. At present, all of these things exist in reasonable balance with each other, but move where the moon is and that balance is quickly ruined. So even before a falling moon actually arrived on Earth, even just a short way into its journey toward us, we'd already be dealing with a high degree of chaos. As it got closer and closer and closer, its gravitational effect on our planet would become more and more intense. By the time it got to within just 1,000 miles of us, we'd be talking whole oceans displaced all over the map, with massive tsunamis washing everything away. Individually, with the moon just a few hundred miles away from us, we would all notice a shift in our body weight, weighing around 10% less than we normally would, with such a significant gravitational influence now pulling at us from above. Collectively, we could see buildings and cities begin to disintegrate even before impact, and we could even experience earthquakes and huge volcanic eruptions as the Earth's tectonic plates are affected too. To a small degree, Earth itself could even appear physically stretched out. Much about this hypothetical reality depends on how quickly the moon is falling, but in the final moments before impact, Earth may well have morphed out of its usual, near-perfectly spherical shape. Most of all of that, however, depends upon a hypothetical scenario where the moon itself arrives to Earth intact. In reality, though, it wouldn't necessarily do that, and similar damage and destruction as what we'd be seeing on our own planet would also be felt on the lunar surface. The key here is that when two bodies approach each other in space, there's something known as the Roche limit, which is the distance where the larger object's pull begins to overtake the smaller object's internal force of gravity. In this case, Earth is the larger object, and the moon is the smaller. As such, the Roche limit for the moon kicks in about 11,500 miles away from us, which means that by the time the moon had arrived to within 1,000 miles of us, or even 10,000 miles, where we could expect all kinds of crazy world-ending things to be happening, it could actually, at least partly, have begun to disintegrate. Not that this would help us out all that much. At this stage, Earth's superior gravity would begin ripping the moon into pieces. Again, the speed of the traveling moon is key to just how significantly the Roche limit could come into play, but whole chunks could now be breaking off as it made its journey toward us. Mercifully, a lot of the debris would get caught, suspended in the sky, forming a ring of rock more than 20,000 miles in length all around us, turning Earth into something like Saturn. Some of the debris wouldn't get caught, however, and would instead rain down on Earth, pelting our once life-enabling world with an extremely close quarters, incomparably dangerous meteor shower. From some perspectives, this breakup of the moon would be a good thing for us, as it would mean multiple, yes, but smaller impacts. On the other hand, it's not as though these fragments of the moon wouldn't still be massive in themselves, with just one of them likely being large enough to level an entire city. But finally, say the moon fell towards Earth and it didn't break up, and all of the earlier mentioned climatological changes did take place because the moon was somehow able to bypass the Roche limit. This isn't exactly what we'd expect to happen in real life, but we also know that the effect of the Roche limit is in part determined by the speed of the approaching object. So if the moon was traveling fast enough, there wouldn't necessarily be time enough for it to be torn apart before it arrived. Or at least most of its main mass would still be as one. So what would the point of impact actually be like now? If it came to pass that a whole moon collided with a whole Earth, what level of destruction could we expect? Well, near total destruction. The highest level reasonably imaginable, and then probably a bit more. Two massive bodies like this crashing into each other would send an explosion of debris flying in all directions. With so much energy released by the collision, there would be blinding lights and massive temperature spikes emitting from the site itself, to the point that it would be an event easily noticeable from far across the galaxy. There's really no telling what shape our planet would be left in, only that it will have been reduced to a splintered, craggy chunk of molten, raging rock. It could well have been pushed out of its once reliable orbit around the sun and left to drift through the solar system. Its rotation speed will have changed. And as for the moon, the fragments of that once iconic resident of our skies will have also been left to float aimlessly through space. There are few doomsday scenarios where the carnage would be quite so severe, and any type of life on Earth would struggle to survive. Humans and mammals and all large creatures will certainly have perished, but even the world's hardiest microbes and single-celled life forms would struggle to re-emerge after this. To put the potential damage a Moon-Earth collision could cause into context, the asteroid believed to have wiped out the dinosaurs, the Chicxulub impactor, is thought to have been somewhere between 6 and 15 miles wide. Again, the Moon, by comparison, is 2,150 miles wide. Not since the Moon was formed will Earth have seen an impact quite like this. But what's really amazing is that even after all of this, even after untold ruin on a truly apocalyptic scale, what's left of the Earth could start again. Over millions of years post-Moon collision, the fragments of both masses could feasibly form into another center of gravity, gradually rounding off to assume position as another new planet. Whether or not this planet could then become habitable, or even whether or not it'd still exist in the same region of the solar system, is impossible to know. But for as long as even a small part of Earth remained, the universe could recycle it in this way. Somewhat thankfully, back in the real world, it's been found that the Moon is actually retreating away from Earth at a rate of about 4 centimeters every year. This brings with it its own set of problems, but it also means that our lunar satellite probably isn't going to redirect towards us anytime soon. In the vast unendingness of space, though, with billions of years laid out before us in the future, we can't categorically say that such an event will never happen. Perhaps it will, for example, when the sun eventually goes red giant. But for now, there's no need to worry. And that's what would happen if the Moon fell to Earth.